download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about limiting reactants. Now in the previous video we looked at being able to calculate how much of something we needed to produce a certain amount of something else. So for example, we looked at this question: calculate the amount of calcium oxide formed from 0.82 grams of oxygen. And we calculated that if we had 0.82 grams of oxygen, we would be able to produce 2.87 grams of calcium oxide. Now if we go back to our conservation of mass, we will remember that no mass is lost or gained in chemical reactions, and that we mean that the mass of the reactants will be the same as the mass of the product. Okay, so if our products are 2.87 grams, then our reactants must have also been 2.87 grams. So then to find the amount of calcium that we needed to react with 0.82 grams of oxygen, we just need to do 2.87 grams, take away 0.82 that comes from the oxygen, and that would leave us with 2.05 grams. So that tells us we need 2.05 grams of calcium to react with 0.82 grams of oxygen, and we will get 2.87 grams of calcium oxide. Now, this is assuming that both reactants have the perfect amount to react with each other to form this amount of product. In reality, one reactant is usually left over at the end and is referred to as an excess reactant, i.e. we've got too much of it. The other reactant is all used up, and because there isn't more of it, it limits the reaction, and it is therefore called a limiting reaction. So let me first explain this idea in terms of making a cake. Okay, so we want to make 10 cakes, and we have enough flour to make 10 cakes, but we only have enough eggs to make 5 cakes. Now, can we make 10 cakes here? No, we can't. We've only got enough eggs to make 5, and therefore we can only make 5 cakes. Therefore, eggs is limiting the amount of cakes we can make. So we can call eggs the limiting factor. The limiting factor. And flour, because we're going to then have some left over, because we only need enough flour to make 5 cakes, because we can only make 5 cakes, we can call flour the excess reactant, because we're going to have some left over. We've got more than we need. Okay, so eggs is the limiting factor, whereas our flour is our excess reactant. Now let's go back to this example here. That's calcium plus oxygen gives calcium oxide. Say for example that actually we only had, so we need 2.05 grams of calcium. Say we only had 1.5 grams of calcium, we would no longer be able to make 2.87 grams of calcium oxide, even though we've still got enough oxygen. So what that would mean is calcium is going to limit the amount of calcium oxide we can make, so we can call, in this scenario, calcium the limiting factor, because we're going to run out of it first. And oxygen, we've got more oxygen than we need for this amount of calcium, therefore our oxygen is called our excess reactant. Okay, so the limiting reactor is the one that runs out first and therefore limits the reaction. The excess reactant is the one that's left over at the end, and therefore we have more than we need of it. So let's go through a bit of a worked example. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. As to what that means. So here we have a question. Nitrogen reacts with hydrogen to form ammonia. in this equation here. 0.5 moles of nitrogen and 3 moles of hydrogen are added together. What is the limiting reactant here? Well, the first thing we need to do is we need to balance the equation. Okay, so I'm going to balance the equation now. Okay, if you don't know how to balance equations, then please make sure you go back to the video on balancing equations. So this is now the balanced equation. So this tells you we need 1 mole of nitrogen. So 1 mole of nitrogen, because there's not a number after the nitrogen, before the nitrogen, needs to react with 3 moles of hydrogen, and that will produce 2 moles of ammonia. That's what that question is telling us. 1 mole of nitrogen is added to 3 moles of hydrogen to make 2 moles of ammonia. So in our example, we have 0.5 moles of nitrogen. So 0.5 moles of nitrogen to make with 3 moles of hydrogen. So what is the limiting factor here? Okay, so if we have 0.5 moles of nitrogen, we need 3 times as many moles of hydrogen as we do nitrogen. Okay, because in our equation it's telling us that 3 moles of hydrogen is needed to react with 1 mole of nitrogen. So we need 3 times as many moles. So that actually means we need 1.5 moles of hydrogen, because that's 3 times 0.5, to react with 0.5 moles of nitrogen. And this will produce 1 mole of ammonia. In our question, we've got 3 moles of hydrogen. Now that is too much. We don't need that amount of hydrogen, which means that that is our excess reactant. And therefore, nitrogen is going to be our limiting reactant, because we're going to run out of it first, because we've got more hydrogen than we need. Therefore, we're going to run out of nitrogen first. So nitrogen is going to be the limiting reactant. So what I'd now like you to have a go at is answering these questions. So first, balance the equation, and then in each of the 2 examples, tell me which one is the limiting reactant. So pause the video now. Okay, so let's go through the answers. First of all, we need to balance the equation. So what you should have got for a balanced equation is this right here. And then in this example, 3 moles of nitrogen and 7 moles of hydrogen. Well, again, we know that we need 1 mole of nitrogen per 3 moles of hydrogen. So if we had, so that's 3 times the amount of hydrogen as we need nitrogen. So if we have 3 moles of nitrogen, we need 3 times as much as that hydrogen. So we need 9 hydrogen. But in this equation, we only have 7. Therefore, this one, hydrogen is limiting, because we need 9 moles of it to react with 3 moles of nitrogen, and we only have 7. So in the next question, we have 0.5 moles of nitrogen. So 0.5 moles of nitrogen. Again, we need 3 times as much hydrogen as we do nitrogen. So if we have 0.5 moles of nitrogen, we need 1.5 moles of hydrogen. We have 2 moles. So there we have more than we need, which means that nitrogen is going to be the limiting factor. So in this example, nitrogen is limiting. So we've there looked at what we mean by limiting factor and how to identify limiting factors from equations. You can now go onto the quiz and answer any exam questions on this topic. And if you need any help and you didn't understand anything, then please do get in contact with one of our tutors who will be happy to help.